This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on consumers and producers surplus. So here's our basic idea. We have a demand curve. So as the demand goes up, how is the price affected? As price goes up, demand goes down. Supply as well. As price goes up, supply goes up. So we have our quantity on this axis, we have our price on this axis. The equilibrium quantity, X bar, P bar, right? This is the demand slash supply that we get for this given price. Here's where the supply curve and the demand curve intersect. That is our point of equilibrium. That'll be something that we'll be looking at. Now we measure the consumer surplus as the difference, in a sense, of the demand curve and that price. But that's an area between two curves, so we're going to integrate the top function minus the bottom function. To get to consumer surplus, we're going to integrate the demand minus the price. Now you see the producer surplus is here. That is also between two curves. The producer surplus will be the integral of the price, top function, minus the supply curve, bottom function. So this is a nice example of how we can use the area under the curve to measure something that's sort of important. So again, there's our equilibrium quantity and our equilibrium price. So here's our formula. The consumer surplus is the integral from 0 to X bar, from 0 to whatever quantity we're interested in, of the demand function minus the price that we're setting. That's our consumer surplus. And our producer surplus is integral over that same region, integral from 0 to X bar, but the top function this time is the price minus the supply function. The supply function is the one that's on the bottom. So here are our two integrals we need to work with, and we'll go ahead and find the producer surplus and consumer surplus looking at those. So what do these things mean? Consumer surplus is the total savings to customers who would have been willing to pay more than P bar for the item, but they can purchase it at that price of P bar. So total savings to customers, in essence, is what this measures. Whereas the producer surplus is the total increase in revenue received by the producers who are willing to supply items for less than a price of P bar, but they are still able to supply them for P bar. So they would have supplied them for a lower price, but the fact they can supply them at this price, this is the additional increase in revenue they get for that. So here's our example. It says find the consumer surplus at a price level of P bar equals 150 for that price demand equation. So let's continue, just cleaning up that typo. We have a price of 150, and the price demand equation is P equals 400 minus 0.05x. So we want to find the consumer surplus at that level. So let's find out what the demand is when the price is 150. So the price is 150, x is the demand. Solving this, we get negative 250 is negative 0.05x when we subtract 400 from both sides. And then dividing by negative 0.05, we get a demand of 5,000. So the demand of 5,000 occurs with a price point of 150. From there, can we find the consumer surplus? And we can take a look at our picture. 400 minus 0.5x looks like this. It intersects at 5,000. The price is 150. That's what we have in green. So the consumer surplus is the area of this triangle. There will be the integral of the top function being 400 minus 0.05x, minus the bottom function. Bottom function is 150. Integrated from where to find this area between? Integrated from 0 to 5,000. Again, top function minus bottom function. Simplifying that, 400 minus 150, 250 minus 0.05x, integral of 250, 250x, integral here 0.05x squared over 2, evaluated as x ranges from 0 to 5,000. Well, the fact that it's 0 is nice because 250 times 0, 0.050 squared over 2. That part will just be 0. So we've got to plug 5,000 into this function to see what our consumer surplus will be. 250 times 5,000 minus 0.05 times 5,000 squared over 2 minus 0. And the consumer surplus we get for this problem is 625,000. Next up, we want to find the producer's surplus for a price level of $67 for the supply-demand equation given below. So this will be an increasing function. It's going up. At that price of 67, we want to find out what the producer's surplus will be. That'll be the integral of the top function, this time 67, minus the bottom function, this one. But we still need to figure out what is the x value that corresponds to that price point. So the price of 67, what will the demand be? Or what will the supply be, actually, in this case? So we should probably call this the price-supply equation. So let me just go ahead and quickly change that. Oh, with the price of $67, what is the supply? We're going to set 67 equal to that. Subtracting 10 from both sides, we get, well, there's our picture first. So here is 67. And apparently the computer is telling us that x was 300. That's kind of nice. Then we have our supply equation growing up like that. So our producer's surplus is this region. So we're going to take 67 minus the lower curve, 10 plus 0.1x plus 0.0003x squared, integrated from 0 to 300, which again was given to us in the graph. We can see that's our region. From 0 to 300 is our region of integration. That's where the supply curve and the price intersect. So 67 minus 10 is 57, but do not forget to distribute the minus signs. So doing that, we get the integral from 0 to 300 to 57 minus 0.1x minus 0.0003x squared. So that's a very common error, is to forget to distribute the minus signs. Antiderivative, 57x minus 0.1x squared over 2 minus 0.0003x cubed over 3 as x goes from 0 to 300. Again, plugging in the 0 is nice. Everything disappears. They're all zeros. But plugging in the 300 will give me 57 times 300 minus 0.1 times 300 squared over 2 minus 0.003 times 300 cubed over 3. And then again, there's all your zeros. And using the calculator, we get a producer's surplus of $9,900. Okay, our next example says find the consumer surplus and the producer's surplus at the equilibrium point. So here is the price-demand equation. Here is the price-supply equation. And the question is, where do those two equations intersect? Can we find that? Well, we're going to set them equal to each other. 50 minus 0.1x will equal 11 plus 0.05x. Subtracting 11 from both sides, adding 0.1x to both sides, we get 50 minus 11, 39.1 plus 0.05 is 0.15x. Dividing both sides by 0.15, we get x bar is 260. So the demand or supply at equilibrium point is 260. The question then, what is the price? Well, we could plug this x bar into either function to get the equilibrium price. Looks like I'm using the demand equation. Plugging in 260, 50 minus 0.1 times 260 is 50 minus 26, or 24. Equilibrium demand supply is 260, equilibrium price $24. From there we want to find our consumer surplus and our producer surplus. So here's a picture of the demand equation coming down this way, the supply equation coming up this way. X is 260, the demand supply is 260, the Y value, the price, is 24. So you can see we have consumer surplus here, producer surplus there. In both cases, we're going to integrate from 0 to 260, and then take the top function minus the bottom function. In the case of consumer surplus, demand minus 24. In the case of producer surplus, 24 minus the supply equation. So consumer surplus, there you go, 50 minus 0.1x minus 24. and the producer surplus 0 to 260 of 24 minus the bottom function is 11 plus 0.05x. Please remember to put that in brackets or parentheses and distribute the minus sign. So quickly taking a look at the integrals, consumer surplus 0 to 260 of 50 minus 0.1x minus 24. 50 minus 24 is of course 26. So we have the integral from 0 to 260 of 26 minus 0.1x. Integral of 26 is 26x. Integral of 0.1x would be 0.1x squared over 2. Integrated from 0 to 260, plugging in 260. 26 times 260 minus 0.1, 260 squared over 2, minus plugging in zeros. In each case, those will be zeros. And the result for our consumer surplus is $3,380. So we also have the integral to do for the producer's surplus from 0 to 260 of 24 minus 11 plus 0.05x. 24 minus 11 will be 13 minus 0.05x as you distribute that minus sign. Integral will be 13x minus 0.05x squared over 2, evaluated from 0 to 260. Plugging in 260, 13 times 260 minus 0.05 times 260 squared over 2. Plugging in 0, 0 minus 0, and our producer surplus is $1,690. And that will conclude this lesson.